From Cape Canaveral Air Force Station in Florida, United Launch Alliance presents live Atlas V launch coverage. At Space Complex 41, the Atlas V rocket is fueled and ready to launch the 7th GPS-2F mission for the United States Air Force.
Range, go for launch. Roger, go for launch.
T-minus 3, 2, 1.
Atlas engine ignition.
Liftoff of the United Launch Alliance Delta IV Heavy rocket.
This is Atlas Mission Control at T-minus 4 minutes and holding. This planned hold is designed to allow launch conductor Scott Barney and his team time to address any last-minute items. However, at this time the team is not working any issues. Our 18-minute launch window opens at 11:23 p.m. Eastern Time. Good evening, and welcome to Mission Control at the Atlas Spaceflight Operations Center. I'm Steve Agin, and I'll be your commentator for tonight's mission. Following liftoff, you'll hear the voice of Marty Malinowski providing live launch vehicle Ascent data. Also following liftoff, I'll be joined by Lieutenant Daniel Cuellar from the Air Force's GPS Directorate. Due to the long duration of tonight's mission, our live coverage will conclude about 20 minutes after liftoff. As I mentioned earlier, tonight's mission is the 7th satellite in the GPS-2F series. This is the second GPS-2F launch on an Atlas V. ULA's Delta IV rocket has launched 5 2F missions. GPS, or Global Positioning System, is a space-based radio positioning system consisting of a minimum of a 24-satellite constellation providing navigation and timing information to military and civilian users worldwide. The signals are so accurate that time can be measured within a millionth of a second, velocity within a fraction of a mile per hour, and location to within 100 feet. Built by Boeing, the 2F series provides improved capabilities for military and civil users and a new third signal, or L5, for communication or commercial aviation and safety of life applications. Recently, the launch team received a final weather briefing from the 45th Space Wing weather officer. The team was told the weather is within the launch commit criteria for tonight's launch. The weather briefing provided the following information. Probability of violating launch constraints is 0%. The ground winds are 10 to 14 knots out of the southeast, and the temperature is 82 degrees Fahrenheit. So, we are proceeding towards liftoff with a planned T0 time of 11:23 p.m. Eastern Daylight Time. United Launch Alliance is using the Atlas V 401 configuration to launch the GPS-2F-7 mission. This is the 47th Atlas V Evolved Expendable Launch Vehicle mission since the inaugural flight in 2002, and the 629th Atlas program launch overall. GPS-2F-7 is ULA's 85th mission since formation in 2006. The Atlas V is produced in Decatur, Alabama and Harlingen, Texas. It is comprised of a common core booster powered by the RD-180 main engine, and the Centaur second stage is powered by the Aerojet Rocketdyne RL-10A engine. On July 16th, GPS-2F-7 was encapsulated within a 4-meter diameter payload fairing, which protects it during ascent. The encapsulated payload fairing was mated to the Atlas V on July 21st. The Atlas V is prepared for launch at the Vertical Integration Facility, or VIF. The VIF is located approximately 1/3 of a mile south of the launch pad. The fully integrated Atlas V was rolled to the pad yesterday. For those watching, you're looking at video taken yesterday at Space Launch Complex 41. Trackmobiles are used to transport the Atlas V and its mobile launch platform to the launch pad, a trip that takes about 30 minutes. The Atlas V rocket stands 188 feet tall, or about 19 stories, and weighs more than 700,000 pounds fully fueled. At liftoff, the RD-180 engine produces more than 860,000 pounds of thrust to begin the rocket's flight. The animation you'll see after liftoff is referred to as Satellite Toolkit, or STK. STK uses real-time telemetry data during the flight to track the path of the launch vehicle beyond the range of ground-based cameras. While the team completes final preparations for launch, let's take a closer look at today's flight. The following profile details the important events of this mission using approximate times.
5, 4, 3, 2, 1, 0, and liftoff of the Atlas V rocket.
The Atlas RD-180 main engine ignites to lift the vehicle away from the pad. Shortly after liftoff, Atlas begins its initial pitch, yaw, and roll maneuvers to attain the proper ascent profile and minimize aerodynamic load. The Atlas V reaches Mach 1, the speed of sound, at 78 seconds. At 90 seconds, the vehicle experiences maximum dynamic pressure. Approaching booster engine cutoff, the Atlas V is burning propellant at the rate of 1,600 pounds per second, traveling at approximately 16,000 miles per hour, and located 62 miles in altitude and 146 miles downrange. Booster engine cutoff occurs approximately 4 minutes after liftoff. 6 seconds after booster engine cutoff, the booster stage is jettisoned. The first Centaur main engine start takes place 10 seconds after booster separation. The payload fairing is jettisoned approximately 4.5 minutes into the flight. Cutoff of the Centaur main engine follows an approximately 13-minute burn. The mission now enters a nearly 3-hour coast phase. At just over 3 hours 18 minutes into the flight, the Centaur main engine is started for a second and final burn. This burn will last nearly 2 minutes. Following the second Centaur main engine cutoff, the mission enters a final coast phase. This coast phase will last nearly 5 minutes. At 3 hours 24 minutes, Centaur releases GPS 2F-7 for the United States Air Force.
RC, LC.
RC.
Verify solar radiation acceptable for launch.
Verified.
LC switch to ready position. All steps are complete prior to the status check.
LC RC1.
Go.
Launch window management plan through into window 0341 Zulu.
Roger, 0341 Zulu.
This is Atlas Mission Control at T-minus 4 minutes and holding. We remain in this planned 20-minute built-in hold as preparations for the launch continue. In a few moments, launch conductor Scott Barney will poll the team for their final go to resume the launch countdown. 27 engineers and managers are polled for system status and readiness to proceed with the launch. This is the final status check before launch for all Atlas vehicle systems, ground systems, the spacecraft, and the U.S. Air Force Eastern Range. The readiness poll includes hydraulics, quad water deluge system, electrical systems, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as launch conductor Scott Barney performs the final polling of the team.
Status check to proceed with terminal count. Atlas systems, propulsion.
Go.
Hydraulics.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems, propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
HASGAS.
Go.
Electrical systems, airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
COM.
Go.
Timer.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor.
Go.
Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
AC's go.
Range coordinator.
Clear to proceed.
Launch director.
The launch vehicle is ready to launch.
Mission director.
This is the mission director. You have permission to launch.
Proceeding with the count. T0 is planned for 03:23 Zulu. Set count to start at 03:19 Zulu.
Roger.
Polling is complete and the launch team has given the go for launch. The countdown will resume at T-minus 4 minutes in approximately 2 minutes from now. From T-minus 4 minutes until launch, you'll be listening to launch conductor Scott Barney and his team performing the final steps in the countdown procedure. At T-minus 3 minutes, the team will secure Atlas LO2 topping. At T-minus 2 minutes, the team will transfer the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur, LH2, and LO2 topping activity. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. At T-minus 40 seconds, the Atlas tanks will be verified at flight pressures, followed with verification of the Centaur tank pressures at T-minus 30 seconds. A final status check of Atlas, Centaur, and GPS readiness is conducted at T-minus 25 seconds. RD-180 engine ignition occurs at T-minus 3 seconds.
On my mark, time will be T-minus 4 minutes and counting. 3, 2, 1, mark.
This is Atlas Mission Control at T-minus 3 minutes 56 seconds and counting. The countdown clock has resumed and we are go for launch at 11:23 p.m. Eastern Daylight Time.
Three minutes. Securing LO2 topping. Atlas tanks to flight pressure. 250.
Just internal.
This is Atlas Mission Control at T-minus 2 minutes 27 seconds and counting. The countdown is on track and we proceed towards T0. Once the rocket lifts off, it'll take approximately 78 seconds to reach Mach 1, or the speed of sound.
$159.
Vehicle internal.
$155.
Launch sequencer start.
$150.
Securing Centaur LH2.
Securing Centaur LO2.
$140.
FCS launch enable.
T-minus 1 minute 30 seconds and counting. The launch vehicle, payload, ground systems, and eastern range are go for launch.
120.
Orcas armed.
FCS count started.
110.
That valve's locked.
This is Atlas Mission Control at T-minus 1 minute and counting.
Status.
This is the Rock. Range is green.
54. $40. Stable at step 3. $28. 25.
Status check.
Go Atlas.
Go Centaur.
Go GPS.
15.
This is Atlas Mission Control at T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and we have liftoff of the United Launch Alliance Atlas V rocket carrying the 7th GPS-2F satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing services for military and civilian users. You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Ejector pressure is good, pump speeds within expected parameters. Continuing pitch yaw roll program, body rates look good. Booster performance looks very good. Pitch yaw roll program is complete. Booster engine continues to operate well. Pump speeds within band. Ejector pressures as well. Mach 1. Max Q. Body rates look good. Booster has throttled down right on schedule. Signatures look good. Currently flying at 1,700 miles per hour at an altitude of 11 miles. Booster engine continues to operate well. Body rates are stable. Coming up on closed loop steering. And Q alpha closed loop steering has been enabled. Body rates look good. Booster continuing to perform well. Pump speeds and ejector pressures are within band. RCS pyro valve has been fired. System is now pressurized to flight levels. Booster engine continues to operate very well, currently accelerating at 3.4 Gs. Flying at an altitude of 33 miles, downrange distance of 53 miles. Current velocity is 5,243 miles per hour. And Q alpha limited steering has completed. And boosters throttled back right on schedule. Engine response looks good. Currently accelerating at 4.6 Gs. Flying at an altitude of 49 miles, downrange distance 103 miles. Current velocity 7,734 miles per hour. And we've throttled back to maintain 5 Gs. Boost phase cooldown is underway. The Pogo pyro valve vent has been fired. And begun throttling to maintain 4.6 Gs in preparation for BECO. Boost phase cooldown is complete. And we have BECO. Engine shutdown looks good. We have retros and stage separation. Looks like a clean SIP. Locks and fuel pre-start on the RL-10. GN2 purge firing of the RCS is underway. We have ignition and full thrust on the RL-10. And we have indication of payload fairing jettison. Looks like a clean jet.
This is Atlas Mission Control at L plus 4 minutes and 44 seconds. Marty Malinowski just confirmed payload fairing jettison and all systems continue to operate nominally. The mission is in the first of 2 Centaur engine burns as the Atlas V travels in a northeasterly direction up the east coast of the United States. Our next event, Centaur main engine cutoff, will occur about 12.5 minutes from now. I'm now joined by Lieutenant Daniel Cuellar from the Air Force's Global Positioning Systems Directorate. Lieutenant, thanks for joining me.
Thanks, Steve. It's an honor to be here for the 7th GPS-2F launch.
What is the current status of the GPS-2F program?
Well, the GPS-2F program is in the final stages of delivering the remaining GPS-2F satellites. So currently there are 6 of 12 satellites on orbit, and they are actually meeting mission requirements. So 3 additional satellites have been accepted by the Air Force and are in storage at the Boeing factory. The delivery of the final satellite will be completed and moved to storage later on this year. So the Space Vehicle 8 is confirmed for an October 29th launch, also here at Cape Canaveral Air Station. Our current plan is to launch the remaining 5 2F space vehicles by the end of 2016.
What is the current status of the GPS constellation?
Well, the GPS constellation remains healthy, stable, and robust, with 31 operational satellites on orbit, providing position, navigation, and timing to users around the globe. 21 of the 31 satellites have remained operational well past their design life, demonstrating the high-quality engineering and mission assurance practices used in the program.
Lieutenant, how did you become an officer in the Air Force?
Well, I came from a small town in Central California. I went to school there. I started attending college and decided, maybe it wasn't right for me, so I enlisted in the military back in 1998. So after I became a sergeant, it was recommended by my leadership to go ahead and apply for a commissioning program. I got accepted and became an electrical engineer, and then went to officer training school and became an officer of the United States Air Force.
What was your path to your current position?
Well, after earning my degree in electrical engineering, the Air Force categorized me as a developmental engineer, and based on that, there were so many places I could have gone. I was fortunate enough to get stationed in El Segundo, California, working at the GPS Directorate, and it's been a great fit. The GPS Directorate focuses on development and production of technologies to support both civilian and military GPS users worldwide, both now and in the future.
And how does your job help the GPS mission?
I work in the GPS User Equipment Division, and we're responsible for the acquisition of GPS user equipment for military applications. Our mission is to deliver sustained, reliable GPS capabilities to America's warfighters and our allies around the world. This is done by developing and testing modernized equipment that's operational in any environment. My job is to work integration between military GPS user equipment, or MGUE, and military platforms. We've already begun MGUE integration efforts on the Navy's Arleigh Burke-class destroyer, the Army's unmanned aerial vehicle, called the Raven, the U.S. Marine Corps and Army's Joint Light Tactical Vehicle, and the F-15E Strike Eagle.
Lieutenant, why do we need M-code and MGUE?
Well, M-code's a new, highly encrypted GPS signal that'll be used solely for military purposes. To access M-code, you need an M-code receiver, and currently, the only M-code receivers capable of using M-code are MGUE. So these receivers will provide increased resistance to jamming and will allow for the differentiation between authentic and false GPS signals. One of the main objectives of MGUE, though, is providing global positioning, navigation, and timing to our military forces and our allies while denying the use of GPS by our adversaries.
Well, Lieutenant Cuellar, I appreciate you taking your time to join us this evening, and we thank you for your service to our country.
Thanks, Steve. It's been a pleasure to be here.
Thank you. This is Atlas Mission Control at T plus 8 minutes 36 seconds into the flight.
Excess oxidizer and controlling near nominal mixture ratios. Engine performance continues to look good. Chamber pressures, LOX pump discharge, and fuel venturis within expected bands. And Centaur has achieved the head-on gate at this point. Currently flying at an altitude of 233 miles, downrange distance 1,220 miles, current velocity 12,985 miles per hour. And Centaur continues to progress well through the burn. RL10 performance looks nominal. Thermal conditioning firings look good. Line temperatures have warmed to bottle temperature. And Centaur is making a fuel-rich correction at this point. Engine response is appropriate. Chamber pressures are stable. Some slight pump speed increases due to the change in MR. And Centaur is currently flying at an altitude of 236 miles, downrange distance 1,743 miles, current velocity 14,597 miles per hour.
This is Atlas Mission Control at L plus 12 minutes, 4 seconds into the flight. We're approaching the end of the first of 2 planned RL-10 Centaur engine burns. The Atlas V and GPS satellite are flying over the North Atlantic Ocean, south of Greenland, and about midway between North America and Europe. Our next event, the first main engine cutoff, or MECO-1, is scheduled to take place about 6 minutes from now. While we wait for the next mission event, let's take a look at a video highlighting the important capabilities of the GPS Block 2F satellite.
The Global Positioning System is a marvel of the modern age. It consists of more than 30 GPS satellites circling the globe over 12,000 miles above us. In tightly controlled orbits, these U.S. Air Force satellites continuously transmit their signals to Earth. An extraordinary technology, GPS enables anyone with a GPS receiver to determine their precise location and the exact time anywhere in the world, usually within a meter and within a billionth of a second.
GPS is ubiquitous. It's everywhere. It's in our cars, it's in devices that you use to determine how far you've run or ridden your bicycle.
With billions of users and countless devices, it is easy to take GPS for granted. But it is the essential platform for innovations which enables us to do everyday things like buying gas at the pump and getting directions, and amazing things like tracking ice melts and saving lives in ways that were formerly impossible.
The beauty of the GPS system is that it's available for everyone. The cost of entry for any user is simply the cost of their receiver.
Boeing helped make GPS possible. It's been the U.S. Air Force's prime contractor on 4 major programs, replacing the initial group of satellites as their service lives were completed. Overall, Boeing has produced 2/3 of all GPS satellites, more than 40 in all.
Satellites are normally built in a low volume, perhaps 2 or 3 at most. And they're usually sit in one spot, and resources are brought to the satellite.
Now, to ensure that GPS is available whenever it's needed, Boeing has changed how satellites are made. It's producing 12 new GPS satellites using a streamlined process based on its efficient and advanced airplane assembly line techniques.
Our goal is to have the highest quality.
These new satellites bring next-generation performance to the GPS constellation we all use every day. As a result, they are delivering new levels of accuracy to what is already a remarkably accurate system, and they are being built in a much more efficient way, ensuring that this essential technology is available when we need it.
This is Atlas Mission Control at T plus 14 minutes, 53 seconds into the flight. The GPS 2F mission lifted off from Space Launch Complex 41 here at Cape Canaveral Air Force Station at 11:23 p.m. Eastern Time. The mission is nearing the end of the first of 2 Centaur second stage engine burns. Our next event, MECO 1, is scheduled to take place a couple of minutes from now. Let's go back to Marty Malinowski for the call.
Centaur tank pressures are stable. Storage bottle pressures look good. Plus and better voltages are as well. Body rates controlling down the middle. One minute to MECO. Centaur is flying at an altitude of 158 miles, downrange distance 3,423 miles, current velocity 20,142 miles per hour. RL-10 continues to perform well. Pump temperatures are as expected. RCS line temperatures look good. Coming up on MECO momentarily. And we have MECO. Engine shutdown looks good. FTS receivers have been secured. 4S settling has begun. Fuel tank has been bent.
This is Atlas Mission Control at T plus 17 minutes 46 seconds into the flight. Marty Malinowski just confirmed cutoff of the RL-10 engine. The mission has now entered an extended coast phase which will last about 3 hours. Following MECO 1, the mission trajectory changes to a southeasterly heading, flying over Eastern Europe, Turkey, and Saudi Arabia. It will continue in a south-southeasterly direction over the Indian Ocean. Following a short second burn of the RL-10 engine, the Centaur second stage will deliver the GPS-2F-7 satellite to semi-synchronous orbit over the Southern Ocean, north of Antarctica. Separation will take place about 3 hours 24 minutes after liftoff. I'd like to thank Marty Malinowski for his support of tonight's broadcast. I'd also like to thank Lieutenant Dan Cuellar.
Thanks, Steve. I appreciate the opportunity to discuss the GPS mission.
Thank you. For more information about the Atlas V and this mission, please visit our website at ulalaunch.com or follow us on Twitter and Facebook. We'll leave you now with another look at the liftoff of the Atlas V rocket carrying the Air Force's 7th GPS-2F satellite. I'm Steve Agate. On behalf of the entire ULA launch team, thank you for joining us and have a good evening. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, ignition, and we have liftoff of the United Launch Alliance Atlas V rocket carrying the 7th GPS-2F satellite for the United States Air Force. The Global Positioning System provides worldwide positioning, navigation, and timing services for military and civilian users. You're now hearing the voice of Marty Malinowski providing launch vehicle ascent data. Let's listen in for mission progress.
Ejector pressure is good. Pump speed